Okay, in lesson 8.2, we're still going to be dealing with exponents, all right? But we're going to be dealing with some different rules. Today we're going to be talking about when we have exponents that are 0 or negative, okay? So, let's get into it. First of all, this is the most simple example you will ever see. Anytime at all, you have an exponent of 0, your answer is always 1. It does not matter what your base is. If the exponent is 0, your answer is 1. So 1/4 to the 0 power is 1. Negative 5 to the 0 power is 1. 0 to the 0 power is 1. Okay? What if I would have one like this? A to the 0 power. What do you think that's going to be? 1. It never changes. What if I had something like a squared plus b times b squared to the 0 power? This 0, because it would be distributed to everything, what's 2 times 0? 0. What's 2 times 0? 0. My answer would be 1. Okay, so anything to the 0 power is 1, no matter if the base is a letter or a number. Okay, now negative exponents. These are a little trickier. 0 is super easy. I can never have a negative exponent, okay? And if I do, the only way to make it positive is to take the reciprocal of your base. You say, okay, well, what's the reciprocal of 2? Well, let's write it as a fraction so it's really easy to see. 2 over 1 is 2 as a fraction. So if I flip that, this is my reciprocal. The exponent has to stay with the same base. So the exponent just moves down here with a 2, and because I did the reciprocal, because it moved from the top to the bottom, that's what made it a positive. So now I have 1 over 2 squared, which is 4. And this would be my answer. So anytime you have a negative exponent, you can never keep it negative. You are not allowed to have a negative exponent, okay? But what happens if it's already in a fraction, okay? Again, reciprocal. What's the reciprocal of 1 over 3? 3 over 1. Do I even need to write it over 1? No, I can just write 3. And because I did the reciprocal, that makes that exponent a positive. I'm sorry, that would be a negative 3, okay? Because I did the reciprocal, that makes that positive. Again, remember, whenever you type negative 3 in your calculator, it has to be in parentheses. To the 4th power is equal to 81. You can never have a negative exponent. Okay, let's do some more of those. All right, let's look what I have. First of all, before I do anything, let's follow our rules that we learned in 8.1, which is 4 and 4, those are the same bases, so I keep my base and I multiply the exponents. What is 3 times negative 3? Negative 9. Can I have a negative exponent? No. So let's write this as a fraction and let's flip it. 1 over 4, because I flipped it, that made that exponent a positive. Now write 1 over 4 to the 9th power is, let's plug that in our calculator, and we get 262,144. And this would be my answer there. Okay? Oh, I'm sorry. I totally did that wrong. Erase that. What are you supposed to do whenever you have the same bases and their exponent and they're being multiplied? We add the exponents. What's 3 plus negative 3? 0. What's anything with a 0 power? 1. There we go. That makes that much simpler. Okay? What happens here? What would I need to do with this negative 2? Multiply. So what's negative 2 times negative 3? Positive 6. Well, that fixes the negative exponent, right? So let's do 2 to the 6th power in our calculator, and I get 64. And lastly, let's multiply what I have inside here. Negative 5 times 2 is negative 10 to the negative 2 power. Well, I know I can't keep that as a negative exponent, so I flip it. I get 1 over negative 10. and that becomes a positive. Now, it doesn't make the base a positive. It just makes the exponent a positive. And I get 1 over, again, make sure you plug it in parentheses in your calculator, 100. Okay? So that's how we deal with negative exponents.